experience assessment. And then at the end of the talk, I will come a little bit to gaming. And you will see that the fundamentals take a larger part than the application gaming part, because the gaming part is only interesting to a couple of you, and I think that the other part is more interesting to everybody. So the concept of quality has been debated for, I would say, approximately 20 years now, or at least for the last 20 years, there has been a constant debate about what quality is. And this debate was triggered from two sides. First, the developers' side, and that was actually what people meant when they talked about quality was actually performance. There's no universal definition of the word performance, but there are some definitions stating that performance is the ability of a unit to provide the function it has been designed for. And if you have a unit with a well-defined function, so if it's well specified what the unit has to do, then you can measure the performance. And that actually led to the definition of quality of service, which says it's the collective effect of service performance which determines the degree of satisfaction of the user of a service. There is a newer version of this E800 definition that I have used this old one because it's still pointing out that quality of service is actually performance. It's not quality. It's not QoE. But some people misunderstand QoS as QoE, and this is what I would like to avoid here. And then there is the user's point of view. And on the user's point of view, we had a long-standing definition of quality from a colleague of mine, Ute Jekosch, who said that quality is the result of appraisal of the perceived composition of a service with respect to its desired composition. That was a definition we have used for at least 15 years, which proved to be quite satisfactory. There was in parallel a definition of quality of experience from the ITU, which says it's the overall acceptability of an application or service as perceived subjectively by the end user. This is not completely wrong, but it's also not completely true, because acceptability is just one result of a quality of experience, and which is only partially determined by the quality of experience. There are a couple of other influencing factors on acceptability. So recently, very recently, which means last week, the study group 12 of ITUT agreed that this is not a good definition and that they would rather stick to a more modern and newer definition of quality of experience. And that newer definition comes actually from a quality white paper developed in the QoE-Net community. But it has origins which are beyond that point. Actually, it's resulted from a Dutch seminar in 2009, where it says quality of experience is the degree of delight or annoyance of the user of an application or service. And then there are a couple of afterthoughts. It results from the fulfillment of his or her expectations with respect to the utility and enjoyment of the application or service in the light of a user's personality and current state. It clearly states that the user determines, it depends on the user, depends on the expectations of the user and on what the user wants to do. This is all very important for quality of experience. And the first sentence, as far as I know, has been taken over now by ITUT Study Group 12 during their meeting last week as the definition of quality of experience. And the ITUT Study Group 12 is the lead study group for quality of experience. So this is kind of important step we have done with the definition. There are also some notes about what service is and also what acceptability is. And it states that acceptability is the outcome of a decision which is partially based on quality of experience, and then there are other influencing factors which come in addition to that. So that's about quality and quality of experience and quality of service. And in this picture, I briefly summarized what the two viewpoints are: quality of service from the service provider's point of view, quality of experience from a user's point of view. And of course, the service providers are nowadays interested in providing high quality of experience. So the target for optimizing their services is no longer quality of service, but is quality of experience, or at least it should be. And this is what the QoE-Net project is all about. So this is something which is important. What is also important in my terminology is that I will use the term quality elements for things a system or service provider can manipulate, physical elements, algorithms, and so on, something which you can change in order to influence the quality of experience. And the quality features are things which are perceived by the user. And there's usually no one-to-one relationship between quality elements and quality features. There is a, you can try to map quality elements to quality features in terms of a quality prediction model. But it is, but this is only a prediction of quality of experience. There comes in a question, why you have only design on the left? Because the design, service design is something which can manipulate the quality elements. It cannot directly manipulate the quality features, but it can only hope that a change of the quality elements will result in a change of the quality features on the user side. So there are some more input, some more question. You should also have employment and management. No, in this one, I don't have an employment. It's not a process model of quality optimization. So we are not talking about a quality engineering life cycle. I'm just stating some definitions and what the difference between quality of service and quality of experience is. What you do in quality management is you manipulate the quality elements and hope that it will result in a better quality of experience. And if you do that continuously in the monitoring process, then you rely on measurements of quality elements, but you don't rely on measurements of quality features. You just rely on predictions of the quality features. Okay, the last slide for this thing is related to processes. This is a now classical picture about the processes which are involved in the quality judgment process. What you see in the dashed box is the user, and there are some processes. These are the round things, and there are some variables or states which you can, which are in these squared kind of lines. What we all agree upon is that there is something physically happening to the user. We call that a physical event, and I will use that term again when I come to the classification of what happens really inside the user. And then there is a perception process, and this is something which not everybody agrees on, there should also be a reflection process. So we should be able to name and describe what we perceive. And then after that, we call that a quality feature. There's something before which we call the perceived nature, and we are still on the right-hand side of this picture. The same type of processes and the same states or variables are on the anticipation or expectation side, and that's what you see on the left-hand side. And what makes out quality is the difference between what the user perceives and reflects about, so this quality features, and what he expects or desires, and that's the desired quality features. And the quality is actually the result of a comparison between the two. You can, some types of quality models, you really model this as a kind of difference, mathematical difference, like the Euclidean distance, for example, between quality features and perceived quality features and desired quality features. But this cannot always work, mostly because in most terms, you cannot clearly describe what the desired quality features are. You might extract the perceived quality features from the physical signal. You might extract what is audible, what is visible, using some type of perception model, which goes perhaps down even to nerve impulse fires. But then at the end, you don't know what is on the desired side. So this does not help you a lot. But in some types of models, it's implemented that way. What is important is that this outcome perceived quality is something which is also in the user, which means that in order to get access to it, we need to ask the user to describe it. And this is actually the quality rating. This is your MOS rating, which you have at the end of a test. And between the two, there is an encoding process. And if the encoding process is not well organized, for example, if you give the wrong scale to your test participants, or if the test design is wrong, then your results will also be wrong or misleading. So this is a very important thing. Perceived quality is not something you get directly, but you can only indirectly guess it through a proper implementation of a test and instruction of the user or a test participant in order to provide you that that's something that perceived quality or quality event, we'll call it in the future, which happens inside the user. There are some response modifying factors, mainly test environment, for example, which is a response modifying factor. If you put the user in the wrong test environment, he will trigger the wrong expectation, the wrong desired nature, and the wrong desired quality features, and then your result will also be wrong. Wrong in the sense not meaningful for the purpose of your experiment. So this is something which can modify the outcome of such a test. Now, we have only talked about the perception and judgment processes, but if you go to an interactive service, you might also have interaction between a user and the system. And this is what I try to illustrate on this, slide. It's a taxonomy of different influencing factors, which you see on the top layer. Interaction performance aspects or performance metrics, which you see in the middle layer with these two ovals. And then on the lower end, you see the quality of experience aspects or features, quality features. On the upper hand, the influencing factors, these are definitely quality elements as far as they are in the hand of the service provider, like your system factors, which we separate into functional or task factors and agent factors. But then there are also factors resulting from the context of use, from the physical context of use, we call them environmental factors, and from the more operational service logic point of view, opening hours, costs would be service factors, for example. And then you have user factors, which may be either static, in the sense that they remain constant throughout your experiments and experience, or they may change dynamically. For a user, for example, a user might get used to some disturbances, or a user might learn how to interact with the service. This is a dynamic user factor. On the layer below, I have depicted some performance aspects which you can measure, and I will start with the right-hand side because that sounds more logical for you, that you can measure, for example, the input performance of a system, whether the system reacts to user input, whether the modality is appropriate, and whether the system is also able to make meaning out of the user's input. This is important, for example, if you have something like a transaction system, an interaction with some website or something like this. Then the system should be able to do that. And then it should be able to manage the interaction, which I call dialogue management here. But it doesn't necessarily relate to speech-based interaction. It can be whatever type of dialogue between a website and the user, or an application or a user. And then on the output side, you need to decide on the appropriateness of certain modalities and of the content for certain output, and then whether the form is also appropriate. For example, if speech is intelligible, if characters are legible for the user, if a graphic is understandable for the user, all that would be the performance of the output. And then we jump to the next oval, which is the user. The user also tries to capture this information. So there's some perceptual performance, which you can measure, for example, in terms of perceptual effort. And then there is a kind of interpretation and interaction workload, which is linked to it. That is something we could measure, for example, in terms of cognitive workload. And then there is some response from the user, action response, whatever type of action the user takes in order to address information to the system. So we're running through these two loops, and that's still all performance. This is something which people try to quantify quite a lot. They try to quantify interaction with the website or with the game or with the spoken dialogue system or any other application app. And they try to do that on this performance level. What is unfortunately missing is the link between this performance level and the quality of experience. And the quality of experience aspects I've depicted on the lower side. We know quite a lot about the interaction quality in terms of how users judge input, how users judge output, how users judge the cooperativity of a system. And I will show you some example directed to gaming in the last part of the course. But then there is more to it. For example, on the functional side, there's something like effectiveness and efficiency. These are the key components of what we call usability. But there's even more like learnability and intuitivity. That's also part of the functional side of user experience, which we could call ease of use. And then we know that in addition to that, there is a non-functional or hedonic side, which is influenced, for example, by aesthetics, the personality of the system, by the appeal, which may result in joy of use. And both ease of use and joy of use are, in my interpretation, subsumed under the term usability. Some people would prefer to see the term user experience here and would only use the term usability for effectiveness and efficiency. But this is not completely true because usability also includes user satisfaction. And then there is also the functional utility for performing a certain task, which I depicted on the right-hand side, which results in usefulness. And all that taken together may result in acceptability of the service. And acceptability is really a purely economic metric, which describes how many users of your target group in percent-wise adopt the system later on and are willing to use that on a continuous basis. This is what we call the acceptability. And people readily mix up user experience with acceptability, or quality of service with acceptability, or quality of experience with acceptability. That's all not the same. So we have to be careful. If we want to measure acceptability, for example, for implementing business model, joy of use and ease of use might be factors, but there might be other factors influencing them, like costs, service availability, and all that other stuff, advertisement, marketing, and so on, social influence from the society, from my friends, and so on, which may play a role here, which we usually don't measure when we do such experiments. There's another question. Can you describe the difference between acceptability and acceptance? Yes, there is a small difference, but it's not very clearly used. So some people say acceptance is what I actually measure, and acceptability is whether in principle a user would be willing to do that choice. This is a very tricky difference, because in many cases you might not be able to measure something in a field test in a real usage situation. So one could say acceptance is what you measure with a real service, and acceptability is something with you measure in a laboratory experiment, or with a beta test or something like this. But it's not, there's no really very clear definition. It's also quite difficult to find a definition of acceptability. The one I've just cited is stemming from a Euroscom study a couple of years ago, where they also discussed amongst the service providers, among the telcos, of what could be acceptability. So this is why I used this one. Still some people are typing. Yeah. Afsa is typing, and Navajit is typing. Okay, there's some more. I would like to find out what differs usability and usefulness. The usefulness is whether the user finds something useful or not, whereas usability is usefulness is not clearly defined. Usability is clearly defined as the effectiveness, efficiency, and user satisfaction with which users reach certain goals in particular environments There's an ISO definition for usability. Usefulness, there's not. Usefulness is more that the user really feels that something is useful. Some more questions? Apologies if a naive question, but should cost be a major factor in QoE? Very good question. I would keep cost out as a direct influencing as a QoE aspect. For me, cost is a service factor, which you see in the middle on the top level. It's something which I can give to my service, and then it influences the requirements of the user, the expectations of the user, and then also the judgment of the user. But this is something which you can manipulate as a service provider, the costs. So for me, this is not a quality of experience aspect, but it's more on the upper level, on the influencing factors level. Some more questions. Can something not useful be usable or vice versa? Yes, it can. Very easy. There are some very easy to use services. Easy to use means usability, but it's not useful for anything particular. So users might not adopt such a service because they might get their tasks done in a different way. There might be very usable apps or websites for a certain purpose, but you don't use them because you get your tasks done in a different way you prefer. Okay, hope that I answered those questions. So I will step to the next part of the course, if that's okay. Okay, the next part of the course is some more basis, and I'm not a psychologist, I have to point that out, but I'm addressing this point from a psychophysicist's point of view. So I'm trying to give you some fundamentals of psychophysics, which I find important for judging quality and usability and quality of experience and properly designing experiments for this. And I'm sorry if I'm doing that on a quite formal and system level, system directed point of view. But I think it can be really helpful, especially for an engineer. You are most engineers or computer scientists. I think for an engineer can very easily think in terms of block diagrams. And I presented the user in a block diagram in the end. And before doing that, I will also have some notions of psychophysics. Psychophysics is the science which investigates the relationship between physical events and perceptions. It's a science. It's not something voodoo. It's a real science, and there are a lot of scientists. There are conferences around it. Some engineers look at it with the kind of doubt. That's not the case. That's not justified. What we need in order to make this a science is that we can measure it. That is, we need quantitative descriptions. And we need descriptions of both the physical side and the perceptual side. And that's actually the relation, what psychophysics is about, the relation between physical and perceptions. We call a physical event an event which is determined in space, time, and character. For the sake of simplicity, I will use here a sound event because I'm a speech person. But if you prefer to use a visual event, then that's fine as well. It has the same implications. An event is something which is determined in space. Where does the sound come from? Where's the picture? Then the time, when does it arrive? And the character, which could be, for example, sound pressure level, spectrum, PSNR, whatever you might want to describe your physical event with. This is a physical event. And then there is a perceptual event, which would be here an auditory event or a visual one, which is determined again in space, but that does not mean where the sound does come from, but where do I perceive the sound? The time, when do I perceive this event, and the character. The character is something which is subjective here for the perceptual event. It's something which you can measure instrumentally for the physical event. There are physical events which provoke a perceptual event, a sound which you can listen to. There are other physical events which you cannot perceive because they are too quiet, because they are outside your perceptual frequency range, something you cannot see because it's too quick or because it's not visible to you. So there's not a one-to-one relationship. Not every physical event results in a perceptual event and vice versa. There are also perceptual events, by the way, but there's no physical event related to it. For example, if you have a tinnitus, then you hear something and you can really hear that. It's a perceptual event, but there is no physical event reaching your ear. So this is no one-to-one relationship. Now, I think it's different to distinguish between the physical events and the perceptual events, because we are in two different worlds, and the test participant is the one who links these two worlds. And what we usually after is after a quantitative description. That is, we are doing a measurement. A measurement for me is the entirety of all activities in the measuring chain, up to determining the value of a dimension. And the thing we measure is called the measurand, which can be the brightness of a video, or the loudness of a sound, or the overall quality of a video, or that could be something we could measure. In psychophysics, that's usually a perceptual thing we want to measure and not a physical thing. So we are after the perceptual event. And what we do in order to do that is the scaling process. There are some people who say scaling and measuring is the same. For me, it's not the same. The scaling is really only the concrete processes which you do in order to determine the value of a dimension. And all the rest around, all the test setup and so on, it's part of the measurement process, but it's not part of the scaling process. And if it's a psychophysical measurement, it's a measurement which involves human test participants as kind of measurement organs, so kind of subjective beings which are necessary in order to determine this perceptual event. Some people, this is a warning, some people like to call a psychophysical measurement a subjective measurement, and an instrumental measurement an objective measurement. I will tell you in a minute why I think that objective measurement should be deleted, because there's nothing objective in an objective experiment measurement, but also because a subjective measurement can as well be objective in nature, and that's when we talk about the objectivity of a measurement. We'll come to that in a minute. This is one requirement, but the most important requirement of a measurement is, of course, that it validly measures what it should measure. So if we are after determining overall quality, then the measurement should determine overall quality. If we are after brightness, then the measurement should determine brightness. If we are after something else, then the measurement should do it. And this is ensured by a proper scaling process. What people mostly check is not the validity, but the reliability. That is the consistency of a set of measurement with respect to repeated tests or parallel tests or internal test consistency. These are all criteria for reliability of a measurement. And there's a nice picture illustrating the difference between validity and reliability. If your target of the measurement is determined by this kind of target circles, then a measurement with high reliability and high validity would look like this. A measurement with high reliability and low validity would look like this. So it still has a very narrow standard deviation. It has a good repeatability of the results, but it does not measure what you actually want to measure. This would be a measurement with respect to low reliability and high validity, and then this would be a completely useless measurement because it does not measure what you should measure, and it does that also in an imprecise way. How can you check validity? Was the question from Werner. I will go back. This depends really on the type of validity measure you are after. Parallel test reliability would be that you compare two strictly comparable types of tests. So you carry out two parallel tests with the same type of test participants, all the same characteristics, and you determine the correlation between the measurement results. Retest reliability would be you repeat the measurement with the same test participants, and then you see whether they are still stable. And internal consistency is you use correlations between partial results which come from the same type of measurement. So you could, for example, repeat some questions, repeat some stimuli in the test, and could therefore determine the internal consistency of your measurement. And there are different types of correlations depending on what type of scaling you have. I hope that this explains a little bit how you can do that. Okay, this was the slide we've already seen. There are some more criteria for subjective measurements. The objectivity, we have talked about objective measurements. The objectivity is the degree of interpersonal agreement between two measurement results, but here in the sense of independence of the experimenter, not in the sense of independence of the test participant. Why not? Of course, we try to have test participants which are somehow representative. I will come to that term in a minute. But a test result will always depend on the test participant. It must depend on the test participant because quality is something which is relative. You determine the difference between what is perceived and what is expected. So the test participant has a certain memory, it has a certain expectation, and you want to take this into account. So you can select test participants with a certain memory inside. This is not what you want to rule out if you want to have an objective measurement. What you want to rule out is the dependence of a certain person who carries out the experiment. So if I'm doing an experiment here, it should result in the same results as if AFSA would do it in Plymouth, or someone would do it at EPFL or wherever. So we should all agree to the same standards of how to carry out this experiment. Then it's an objective experiment. But if we are doing this experiment with test participant, it needs to be a subjective experiment. And this is why I said at the beginning, we want to do subjective experiments which are objective. Now, this objectivity is mainly used for models, for prediction models, where it makes sense. But the prediction model also has been established with the help of subjective test results. And you want to model the average of these subjective test results or the medium or something like that. So your model necessarily tries to predict something which is subjective. So how can it be not subjective? So this was something where we can discuss for hours. I just wanted to bring to your attention this difference. There are some other side criteria: economy of a measurement, utility, comparability of results, standardizability, and even more. These are kind of minor criteria for designing a good measurement. Now, coming back to the test participant, when we carry out a subjective test, we mostly assume that test participants somehow work the same way. And this is something which is known for a while. So I state here something from 1963, which says that the physiological, psychological parallelity of the processes which I can observe in myself justify the assumption that another person, which has the same kind of setup of the body, so has an analog psychological and physiological characteristics, that he or she also perceives analog things with when the physiological processes are the same. We can try to measure physiological processes. Some of us are doing it in quality assessment, and we assume that the people experience the same. We are never sure whether this happens. We can try to describe that in words, but we can never be sure because we cannot get into the body of another person. But this is what we call the conclusion by analogy. This, of course, only works if the internal processes and also the internal memory of the users are the same. So we need to select test participants, users, with respect to criteria which are representative, and of course only those criteria where we think that they are relevant for our measurement process need to be representative, and the others can be whatever values. As an example, if you want to design a video quality test for expert YouTube users, you should be sure that your test participant group is an expert YouTube user, whatever you define the expert, whether it's 10 hours per week or something like that. But this is important. But it may be that some characteristic like whether you have blue or brown eyes doesn't play a role. In some other tests, this particular criteria might play a role. There might be criteria where we don't know, and where we just say, okay, let's go to be on the safe side, let's go for a average distribution of the population. For example, distribution between male and female. As long as we don't know whether this has an influence, we usually go for something where we say, okay, this is representative for the normal population, or for the type of population we are after. So if it's YouTube users, then it might be unbiased towards male users, perhaps. So this is something which we should be careful, because this is the measurement organ we are dealing with. Now, let's have a look into this measurement organ. As I said, I like to think in boxes because I'm an engineer. There are two processes which you have to take into account: the perception process and the judgment and description process. And I've depicted this here as a box, and for simplicity reasons, I refer to this as a listener, but you can refer to it as a viewer if you like, if you work with video. There is a physical event coming in, that's the sound event, that's the sound wave. There is something happening inside the user, which is a perceptual event, in this case an auditory event. And then there is a description of this event, which you can get from the user. So we have ensembles of values for the sound event, for the auditory event, and for the description event. This is in a normal situation. And as already mentioned, there may be sound events which don't trigger an auditory event. In order to get to this description, you have to ask the user to have to give him a certain task, a scaling task usually, or description task, if it's a qualitative experiment. Now let's go to quality. If we deal with quality, we have an additional layer inside this user, because the sound event is, of course, first perceived, then we have an auditory event. But then quality says it's something relative, where you compare what you perceive to what you desire. So there's something which I call the desired characteristics, or the reference, this is why it's called R0, inside the user. And this makes out the quality event. Once again, this quality event is inside the user. So if you want to have a description, we have to instruct the user to describe this quality event. We can also instruct the user to just describe some features of the quality. And this is what we do, for example, in a multidimensional scaling experiment. We can ask about certain features of a visual percept, or of an interaction, or of an auditory event. Then we ask for we don't ask the user to rate it, but just to describe it. That's the beta, which you see on the top hand side. But if we are after quality of experience or quality, then we are on the lower side, the description of B0. Once again, both the auditory event and the quality event are inside the user, so we can only get that through asking. In the end, this is a repeated measurement process where you have an ensemble of different sound events, which I put on the left-hand side, auditory events, which is this H0, and an ensemble of description event, which is this B0. And between those, there are relationships, there are psychophysical relationships. So a sound event may result in an auditory event, H0, and that might result in a description event, B0. We are usually after quantitative descriptions of these events, and these quantitative descriptions are depicted in yellow on the right-hand side, and I omitted the 0 in order to show that these are quantitative descriptions. So a quantitative description of a particular sound event, for example, the sound pressure level, which we could measure, would be the small s, and the ensemble of it would be the large S. There could be a quantitative description of the auditory event, which is the small h, and the description of it would be the b, this lowercase b on the lower right-hand side. So what happens if we are doing a measurement process? If you are doing a measurement process, we are interested in how a auditory event H results from a physical event S. And I use H and S because we are usually interested in quantitative descriptions. So we need the function H as a function of S. Now this is not as easy. H as a function of S, you see here, seems to be quite easy, but it's not as easy if we do it in a psychophysical experiment. We first measure the sound event, the physical event, for example, with respect to loudness or whatever, with respect to sound pressure level or whatever, and that gives us the S as a function of S0. S0 is the instantiation, and the measurement of it is the S. Now we hope that this sound event leads to an auditory event inside our test participant, results in an H0, and that's the perceiving part of our test participant, the first box in our test participant. And then we also ask the test participant to give us a description. And we should ask it in a way that this results in a B0, that's the cross on the scale which the test participant gives us, and that should be representative of H, namely of the auditory event in the test participant. So our test participant has two tasks, the perceiving task and the describing task of the measurement process. And there can be uncertainties or measurement errors in all three of these little steps we have to do. In the physical measurement, there will be an error. The stimuli might not always be the same. They might not be played back with the same accuracy. Our measurement of packet loss or something like that might be erroneous. That's the instrumental measurement. Then the describing part of the measurement organ might be wrong. If we give, for example, wrong instructions, if we use a scale which is not good, then this is a measurement error. And of course, the perceiving part might be different. If we carry out a test in the morning, you get different results from carrying it out in the evening, because from morning to evening, your perception organs are used throughout the day. And if you have been to a noisy party in the evening, then next morning you might have problems with that test participant. We usually inference only the first and the second part of it. And the third part is something which we might want to control if we do an audition test, if we determine visual accuracy or something like that. But we should be aware of the fact that this changes over time. So usually we just model it as a kind of Gaussian variable, Gaussian random process, because we cannot really describe it. Now coming more to the practical side, and that is the use of scales. And I would like to start with a general statement. There is no universal scale which would provide valid and reliable results for all types of measurements. But there are a couple of scales which are good. So I would like to point out about the differences between the scales. But you should be aware that you should be an expert, or at least a small expert in scaling, in order to select the right scale for your measurement. And for this purpose, I give you just a very brief explanation of different scale types. There has been some discussion about scale types since more than 50 years now. There is a well agreed upon classification from Stevens, which says there are nominal scales. These are scales where the elements represent identities, and there is no relation between the identities. So something like 1 is black, 2 is blue, and 3 is green. You cannot say that green is larger than blue. I mean, you can say that 3 is larger than 2, but green is not larger than blue. So it does not make sense to have any order on these effects. But you would have an order on a so-called ordinal scale, where you have a rank order. So the finish in a horse race would be an ordinal scale. You would know this one is first, this one is second, this one is third, but you don't know anything about the distance between two horses in a horse race. You just know first, second, third. If you want to know about the distance, you need to have a third characteristic of the scale, namely the additivity property, which means that you should be able to tell about the distances. An example of such a scale is the temperature scale in centigrades. So if you have I don't know, in Cagliari now we have 25 or 30 degrees, and we could say Cagliari has 10 degrees more than Berlin, which is 20 here. And we can say that the difference between Berlin and Cagliari, so from 20 to 30 degrees, is the same difference as, for example, from Trondheim to Berlin, where it is only 10 degrees in Trondheim. So we can classify the distance. We could not say that in Cagliari it's double as warm as in Berlin or in Trondheim. This wouldn't make any sense on this scale. We could just say this on a scale which also possesses the last characteristic, which has an absolute origin, a 0 point. And this is, for example, the temperature scale in Kelvin, where we can say 200 Kelvin is double as warm as 100 Kelvin. Because we have this 0 point, and this 0 point allows us to establish ratios between elements on the scale. And this is why we call this a ratio scale. The ratio scale has also all the characteristics of the other scales, so it's the best in a scale theoretical point of view. And then the second best is interval scale, third best is ordinal scale, and final is the nominal scale. Unfortunately, there are some other disadvantages of the ratio scale, but I will first show you of how to do some scaling on these types of scales. And the first one for the ratio scale, there's a very simple method which is called the magnitude estimation, where test participants have to assign an absolute value or an absolute magnitude to each stimulus according to the value of their perceptual event, in this type, the auditory event. So we could say we present a reference stimulus and we say this should have a loudness of 10. You could also say quality of 10 if you like, but I work here with loudness. And then you can say if a stimulus is double as loud, then please, test participant, assign this a value of 20. And if it's only half as loud, then please assign it a value of 5, and so on. So you can use, you can directly define ratios. Experience has proven that this works for a large number of basic perceptions. For auditory perception, visual perception, brightness, for example, it works. Sourness, it works, and so on. So that all the different senses follow such a can follow such a procedure. There are some alternatives to it. Some people like test participants not to work with numbers but with scale length. Some people also say we can produce ratios, percentage ratios. Some people say let's rather use 100 than 10. So there are people who think in different categories. If you are a millionaire, then you might prefer the higher numbers. And if you have to count with the euro and the cent, you might prefer lower numbers. So this is a question of personal disposal. There is one particular problem of this nice ratio scaling approach. That is, we don't have an absolute anchoring. So we know that a stimulus of value 20 is double as loud as a stimulus of 10, but we don't know whether the stimulus of 10 is loud or quiet. The scale doesn't give us any hint in this respect. And this makes it quite problematic because we are usually interested in absolute meanings. We want to know whether something is good or bad. We don't want to know whether it's double as bad or double as good as something we don't know. So this is a problem of ratio scaling. Then this is why in most cases people don't use ratio scaling, but they use an interval scaling. In terms of an absolute category rating or degradation category rating task. I will come to the restrictions of this and whether that's really an interval scale in a minute. But these are the classical scales which you know from your recommendations. P800, tells you something about the speech quality rated on a scale between excellent and bad. Or effort required to understand the meaning of sentences is listening effort, or loudness preference, or something like this. Usually you have 5 or 7 categories in order to rank this. And there are a lot of people who say this is not an interval scale, mainly because the distances between the scale labels are not the same. And this is a result of a study from Jones and McManus. And they try to rank these labels on a continuum in different languages. So you have with Luigi, for you, we have this in Italian as well. On a continuum between worst imaginable and best imaginable. And what you see is usually you have kind of same distance between the first 3 labels, excellent, good, and fair, are more or less equidistant. Then there's a large gap to poor, and then there's a very small gap between poor and bad. And interestingly, the more or less the same this occurs for Italian. And you could do that with other languages as well. There are other scales which are more equidistant, like this degradation category scale, imperceptible, perceptible, annoying, and so on. So this is why some people prefer the DCR scale over an ACR scale. What you could do is try to correct for such distances, but most people won't. Most people would just calculate an average of the values, and this already shows you that the average is not something very meaningful because the distances are not the same. There's a question from Peter. Okay, I'll wait for a second. Perhaps before answering this, I will go, because it doesn't come up, I will go with some more scale problems of the scale. So the interpretation of the attributes, it can also be culturally dependent. So we know that, for example, if you have such a scale in Japanese, then people will try to judge more on the positive side than, for example, Europeans and Americans do. The distance of the attributes, I already said, it's not the same. So the scale is strictly speaking an ordinal scale. There are context effects within the use of the scale. So if you have, for example, an experiment where you only have average to bad stimuli, then the average stimulus will get the highest ranking, the excellent ranking on this scale. And if you have the same stimulus in a set of stimuli with everything good, then this will get the worst ranking. So this is a text internal context effect. And in addition to this, we even have a saturation at the scale extremities. So people cannot go beyond the extremities of the scale. And this also leads to some compression at the ends. This compression at the end is counterbalanced partially by people trying to avoid these ends because they anticipate that this might happen. But all this would result in something which is a not very nice scale. Now I come to your questions. The first one from Werner. One could argue that the DCR scale measures 2 different dimensions, right? Yes, this is something which people have criticized, but this is actually the idea of the scale, because they say if there is something which is not perceivable, then you would have this as in the first part of the scale, and then you rank how much the degradation is in case you perceive it. So this is actually the idea of the scale, but you are right that it's strictly speaking, it's not one dimension. Then a question from Peter. There has also been measurements in different languages where the test participants had to put such labels in order. Yes, they have been these measurements. So I know about this one in Italian and English, and there are more. There are even measurements about the meaning of some of those modifiers which you use, like slightly, little bit, and so on. For German, I know that Rohrmann has carried out some experiments and tried to put these modifiers on a continuum. So there's lots of psychophysical literature about this. This is why you should be very cautious with translating labels, because there was you might change the meaning of something. For example, I would anticipate that in German, the literal translation of poor ist dürftig and bad is schlecht. But if you then no, let's put it another way. You all know these nice grading scales from school, right? There are some people who try to use these labels which you put on the school grading. In German, it would be sehr gut or very good is the best one, and then gut is the second one, good, and then befriedigend would be also a translation of fair, and then ausreichend might be a translation of poor, and mangelhaft would be bad. This is a very bad idea to do that, because if you have always been good in school, you might have a completely different understanding from this scale than if you have always been bad in school. But what you want to measure here is not whether people have been good in school or not. You want to measure whether the stimulus is good or not. So you should try to refrain from all which might be a counterintuitive experience of the test participants. So this is something which I would definitely disrecommend, to use labels which you know from other purposes, which have a certain meaning in other purposes. So this is something which can be very dangerous to do. But I've seen several times that people do it. Yes, the paper from Zielinski about scale biases. Yeah, that's also an example. And there's a lot. There has been comparative analysis. The same set of stimuli in English, French, Japanese, and I don't know which other languages they had. So there are a couple of such experiments for sound, video, speech, whatever. Okay, I should accelerate a little bit. So I talked about the problems of these scales. There are some ideas for improvements. This is an improved version, which we have been using a lot. It avoids the saturation at the end, because you have this little overflow areas, I would call them, between ideal and middle between excellent and ideal, and then middle between bad and extremely bad. This is an overflow area. The graphical layout of the scale incites the test participant to use the scale labels as approximately equidistant, although the label meanings might not be. So if you use such a scale, you usually get a better distribution of your answers. It's not the same as the one you have in P910. In P910, you also have such a similar scale, but there's no ideal and extremely bad, and there's not these ticks in the middle, and there's not this bold and the fine grain thing. I think that this one is better probably than the P910 scale, but you can convince Study Group 12 of ITUT next meeting. There are other scales. Some are called Likert scales. That's where you have a statement on top of something, and then you determine the agreement with such a statement. So the system provided the design information, and the user tags either strongly agree or strongly disagree or something in between. This is possible with the continuous scale. This is possible with the 5 or 7 point scale and so on, or just this binary scale where you have something like the provided information was complete or incomplete or something like that. These are other examples which are used quite a lot in psychology and sociology. There are people who have been trying to integrate the advantages of a category scale, namely that you have an absolute meaning of the labels, with the advantages of a ratio scale. And one of the first was Borg, a professor in Helsinki, who has developed this category ratio scale, where he tried to put labels onto you see, it seems to be quite logarithmic, this perceived ratio scale. It has two anchor points, the scale. One is not at all, nothing, that's 0. And then there is a maximum point, which is not given with the number, but only with this point, which you see on the lower end. And Professor Borg is very picky about the layout of the scale. There are different versions. This is called the CR10 scale because it ranges from 0 to 10. There's also a CR100 scale and the CR50 scale. And it's mostly used for measuring perceived exertion and pain. It's not so much used in classical psychophysics, but we have tried that out. It works also quite well for measuring, for example, the disturbance of degradation in speech quality. We have assessed it. So these are some ideas of how to improve the scaling process. Still, what you see most is the standard classical ordinal scale in terms of MOS or the DCR, either with 5 or 7 categories or with this kind of continuous ruler. The last thing with respect to scaling, and then I come for a couple of minutes to gaming, is multidimensional scaling. And this is something which is very interesting and important if you don't know about the features of your quality space. So if you don't know what are the perceptual dimensions the user uses in order to build his information on quality. There are 2 ways to do that. One is called the multidimensional scaling, where you do paired comparisons of pairwise presented stimuli, and then you judge only the similarity of the stimuli. And from that similarity matrix, you determine a space which you try to reduce in dimensionality as far as possible, and then try to interpret it. The method which you use mathematically to reduce the space is called the multidimensional scaling process, and there are different varieties, mathematical varieties. One of them is called the INSCAL, where you do a mapping for individual listeners, individual scaling, that's where the term comes from. There's also an ALSCAL and some others. There are books about methods which you can use for this purpose. We use that, for example, for finding out about the quality features of speech and a video. If someone has paid attention to Falk's poster on the QMX conference, you might have seen the result of such a multidimensional scaling experiment. Here I show you another example of where car sounds have been judged upon, and this has been reduced to a 2-dimensional space, dimension 1 and dimension 2. The problem is you don't know anything about what the meaning of these dimensions is, except from the stimuli. So we have labeled the stimuli with the car marks. Volkswagen, Opel, Toyota seem to be middle-class cars. Suzuki might be a compact car, and then there are the more precious one, BMW, Mercedes, and then you have sports cars on the upper area, and the luxury cars like Rolls-Royce on the lower left area. And you can try to interpret these dimensions. For example, with respect to the sportivity or sportiveness, I don't know how you call this in English, of the car, that might be an interpretation of dimension 2. And whether it's more simple or a precious car might be the dimension 1, which you hear in the car noise. And you might have a certain market target. For example, BMW might want to approach more the sports car, and Mercedes might be more going into the luxury car area, but that might be your marketing argument of where to go to. There's another method of multidimensional analysis, and this is called the semantic differential, where you select a number of stimuli and you judge them on a number of representative scales. What is representative is up to the experimenter. Usually you do a pre-experiment in order to find out about appropriate scales, and then you judge all stimuli on all scales and do a factor analysis in order to reduce the dimensionality. In the end, this should also come up with a very similar space. So what people mostly do is they apply both methods, the multidimensional scaling and the semantic differential, in order to come to something which is stable across participants and across stimuli. This kind of multidimensional analysis is very important if you are after diagnostic information. And during QMX, you have heard quite a lot about this from Nick Zaharoff, for example, who was also always insisting of that this is important to have not just an overall quality judgment, but a more diagnostic information. And these 2 types of multidimensional analysis help you to find such diagnostic information. There are some examples, some more examples. This is something which has been developed for speech. It's called the diagnostic acceptability measure. It's kind of a semantic differential, which has been used for this purpose quite a lot. Okay, that was the second part, and now I have hopefully a couple of minutes, 10 minutes for the last part, if that's okay. And I would like to talk a little bit about games. I will not talk about all things I have in the slide set, but at least a little bit. Gaming is a particular application, a particular type of service, because of a couple of things which make it very different from a normal service. If you watch these boys here, you could think that they could actually be viewing just a TV, but they are not, because you see that they have all the controls in their hands. So they seem to be quite involved in what they are doing, and they are interacting with the service, and this makes it a service which is more complicated than just YouTube video consumption. First, we have to define what a game is. A game is a rule-based system with a variable and quantifiable outcome, where the different outcomes are assigned to different values. The player exerts effort in order to influence the outcome, and the player feels emotionally attached to the outcome, and the consequences of the activity are negotiable. There are some things which I have put into bold. It's a rule-based system, so the game rules have an impact on quality. I might need some power. You can assign values to the outcomes, which is important in order to govern the rules of the game. But what is more important, the idea of a game is that people exert effort. So it's actually the opposite of usability. With usability, we want to reduce the effort. We want to increase the efficiency. No effort to be put in. Here, the effort is something which is very important because it helps. The effort is necessary in order to create a state of flow, so that the player feels attached and involved in the system. And that might be something which is also very important, for example, for something like storytelling, although this effort part might not be so much relevant for storytelling. So there are some things which are different from a productive application, from a normal productive human-machine interaction, web interaction, where people have to click through websites in order to reach certain information. And also different, of course, from media transmission, where you have human-human interaction or pure media consumption. There's no activity, and where transmission quality is just the only thing. So the computer game is something in between. It's human-machine interaction. Sometimes it includes other players. So you play against a player or you play against the machine. It should be entertaining. It should be self-rewarding. The activity is rewarding, and it should be challenging. It should not be easy, in contrast to productive application, which should be easy. And yeah, so it's a different requirement, and that also results in differences for the subjective assessment of such a gaming activity. I've tried to put that in the taxonomy which you have seen at the beginning, and you see that it changes a little bit, because I've a little bit put all the factors on this interaction performance level, where we think that they are important to quantify this gaming activity and to quantify also the network impact on the gaming activity. So we have again the user, and then we have the system, which is separated into three parts: the interface software and the device the user uses as a control. Then the backend platform. In between the two, there is a network. And then on the backend platform, there will be the game running, which has certain logics, certain rules, and so on. And then the output is played back to the user through these steps. On the lower level, on the quality feature level, you also see that there are some other aspects which are highlighted. Interaction quality again, but then there is something like tension, immersion, positive effect, negative effect, challenge, competence, and flow. These are things which have come out from an analysis from a Dutch group of people, where they try to quantify what they call player experience along 7 dimensions, which you see here, and they also developed a questionnaire for this. So what we are after here is not necessarily good quality in terms of good usability, but we are after a good play experience, and that might even involve challenge, and that's a positive thing here in contrast to other applications. I will go through these. How can you address them? The user factors, and I'm sorry for the bad fonts here in this slide. The user factors usually taken into account by selecting the right test participants. For example, classifying into hardcore and casual gamers, or newbies and pro gamers. There are also some classifications with respect to playing style and the intrinsic motivation. Actually, the real answer is we don't know. We don't know how to classify users for the moment. The only thing we do classically is asking for the experience of the user. There are other factors: age, gender, native language. Gender, for example, has shown some impact in the quality judgments. But then also dynamic factors, where the user is emotionally attached to the outcome, whether he is bored, whether he's distracted, and so on. Game genre, there's no classification of games so far. There have been a couple of factors where games have been classified along. So you have these 42 game genres from Wolf. You have super genres like action, fight, flight, and so on. People have classified games with respect to the game structure, so whether there's just one single player playing against the game, or several players against the game, or it's against each other. The game mechanics and the rules, and also the video quality in terms of spatial and temporal complexity has been used as a criterion for classifying games. And it's not yet finished, so we are still not sure what classification of games we should go for. Technical system setup, of course, that's something you know, so I don't have to go into the details here. Context, physical environment has not shown such a big impact so far. We have done some comparative studies in a lab environment and in a field environment, which was not so important, both with respect to the physical context and also the social context, so the people look at you while you are gaming. Intrinsic motivation, extrinsic motivation, we have developed a questionnaire for this, and there are some, of course, some other service factors which you might want to cater for if you carry out such experiments. Then on the interaction performance level, there are things you can measure on the user side, for example, with perceptual effort scaling. As I said, this category ratio scale is used for that, or cognitive workload. Then there are more performance-oriented metrics, which you measure, for example, on the back end. Input and output performance, interpretation performance, rules, reactions of the game, game success, time on game, how long they play, game errors. All this can be measured, and then we come to the interesting part, namely the quality of experience features. Playability has been defined, for example, as the degree to which all functional and structural elements of the game enable a positive game experience. There was some investigation by Engel. Playing quality, which is some kind of game usability, the degree to which a player is able to learn, control, and understand the game. Or aesthetics. We have heard a lot about aesthetics of pictures in QMax. We haven't yet heard a lot about the aesthetics of games. And then player experience, as mentioned, there is a questionnaire for measuring this along all these 7 dimensions: tension, immersion, positive effect, negative effect, challenge, competence, and flow, which is the game experience questionnaire. It's quite long, so it interrupts the playing experience quite heavily. This is why it has been criticized, and we are reluctant at the moment to use it, because we think that it actually destroys part of what we want to measure. And part of what we want to measure is the flow. Flow is the kind of compromise between challenge and abilities, and we want to have a game which is somewhere in the middle of those. And there are some measurement techniques for it, for example, this flow Kurzskala. We also think that physiological measures might be interesting candidates for this. And then we still have to discuss also with the NTNU people about how to measure immersion. the degree of feeling to be another, virtual reality, and the perception of your own physical reality. There's an immersion experience questionnaire. Some people have used eye tracking. So there are a couple of ideas of how to measure this. And then effect, of course, there are classical metrics for effect with respect to the SAM, for example, self-assessment mannequin, or some others. It's also part of the game experience questionnaire, by the way. So this gives you a relatively complete picture of a relatively complex construct, which we call gaming quality of experience. And probably gaming, in my view, it's one of the most challenging applications we can deal with at the moment, because it contains so many different types of media, audio, video. It contains interaction, but it also contains a very particular purpose of the game, namely to entertain. And entertainment is something which is very much related to experience. Entertainment is actually a service which is meant to be experienced in a positive way. And this makes it more complex and more complicated to be measured than, for example, just video consumption. I will stop here. I have a couple of more slides with respect to some activities we are doing in ITU. I will skip those, and also some more considerations on how to take into account these different factors here, but I will skip those as well. We have also made some experiences of which scale to use and so on. I already told you about this flow Kurzskala and the game experience questionnaire with the 2 items. So if you are interested in that, you can look that up in the slide set, because that will be uploaded to the website, and also this effective measurement with respect to the self-assessment mannequin. So there are a couple of examples which I could cite, but I will stop here and leave a couple of minutes for final questions. You already had a couple of questions, I know. No questions. So you are overrun by so much information, I guess. Actually, there was some of the idea of this short course to put quite a lot of information into a very short period of time, but I think that it may have provided you some basis of what needs to be considered if you want to carry out your own subjective analysis of whatever part of gaming experience you are interested in. So there are a couple of people typing. I'm waiting for your questions. Samir and Peter. Okay, why is the quasi-continuous scale so unpopular amongst QoE researchers? Actually, I don't think that's so unpopular. People have used continuous scale for a while now, in video especially. What is yet unpopular is the exact layout of this scale. We have this particular scale you have seen here is part of an ITU recommendation, P851, and we have tried to use it in a couple of internal experiments. It's still unpopular because people stick to what they know. So for speech, the P800 recommendation is something which is not negotiable to ITU team. For the audio people, it's far more popular and common to use these types of scales, but they're also they are more thinking about how they carry out such experiments. There was a question from Samir. Due to the highly subjective nature of games, do you think the quality of games can ever be assessed like this? Yes, I think so. But I think that we most probably will assess not the quality of the game itself. We will address the quality of experience of the player. I think we can do this. And we will probably address how the network and the technical setup of our game affect the experience of the player, and we will be able to do that only for a particular set of games. But this is enough for us because we don't need to have a kind of automatic game design. We don't want to change the game. We just want to have games which are representative in some way in order to assess of how the factors we can manipulate and the factors you are interested in and Sami is interested in. These are factors like network delay, like packet loss, like what is the device type, like the codec used for the video or the audio, and the synchrony of video and audio. And these are all things you can manipulate. And I think that this is something we can deal with, although it's more complicated and there will be more variety of the results than with a simple perception task, with a simple video assessment task or audio assessment task. More questions?
So, if there is no more question, I would like to conclude the course. Before the conclude the course, I would like to tell you that all slides and information uploaded on the wiki, and the video will be uploaded there as well. And thank you very much, Sebastian, for this very interesting course, especially for me. And thank you for attending this course as well. So I would like to conclude this course, or when it's typing. Okay.
Okay, thanks to all of you for participating.
See you
and have a nice evening.
Thank you.
Thank you. Bye.